Hello students, in today's class we are going to discuss about chemical properties of the metals. So here we observe when metal burn in air, what is going to happen. So in general they react with oxygen to form metal oxides. The nature of the metal oxide formed depends upon the metal's reactivity. So what happens when the metals are burnt in air? Some activities are given over here. So here we are going to test all metals combined with oxygen to form metal oxide. This is the observation that we are going to see after completing this activity. So here if you observe, highly reactive metals are sodium, potassium and magnesium. So what happens when burn with the bright flame? They form basic oxides that dissolve in water to form alkalis. Example, magnesium when burned with the dazzling white flame to form the magnesium oxide, MgO. So here if you observe, in general metal when reacting with oxygen it forms metal oxide. Here another example is, so for example copper is heated in air, it combines with oxygen to form copper oxide and it is a black oxide. You can observe the chemical equation here, copper reacting with oxygen to form copper oxide. Similarly aluminium forms aluminium oxide, right? So if it is magnesium, it becomes 2Mg plus O2. It gives 2 MgO. So it is forming magnesium oxide. So water, as I explained, sodium, Na and potassium and magnesium, these three are highly reactive metals in air. Okay, coming to moderately reactive metals, aluminium, zinc, iron, copper, they are moderately reactive metals in air. So what is this moderately reacting? So if it is a highly reacting, it burn with a bright flame. So it is a moderate reactive metals, do not burn easily but form an oxide layer when heated. So for example, aluminium forms aluminium oxide, right? So aluminium Al2O3, a strong oxide layer that protects the metal from further oxidation. This will protect the metal from forming further oxidation. Iron forms iron oxide, a black coating, right? And copper forms a black copper oxide. Just now we observe, that is CuO. When heated, it is formed. And coming to less reactive metals, are silver, gold, platinum. These are less reactive metals in oxygen. So they do not burn in air or react with oxygen under normal conditions. This makes them ideal for jewelry and electrical components. That's why we are using these materials for jewelry making. Due to their stability, they are not getting reacted with the oxygen that is present in the atmosphere. So we can conclude that highly reactive metals burn with bright flames and form basic oxides. So you can observe the basic oxides, and moderately reactive metals form oxide layer that protect them from further reaction, and less reactive metals do not react with air. So this is the conclusion about the reaction of metal with oxygen. So here we would like to learn another concept, that is nothing but anodizing. So what is this anodizing? You can see here. So basically it is a electrochemical process used to increase the thickness of the natural oxide layer on the surface of metals, primarily aluminium. This enhances corrosion resistance, durability and aesthetic appeal to that material. So how this anodizing will be done? So the aluminium object is cleaned to remove the grease and impurities, and we use electrolysis. The metal is placed in an electrolytic bath containing sulfuric acid, H2SO4. So it acts as the anode and the cathode is placed in the solution. When an electric current is passed, oxygen ions react with the aluminum surface, forming a thick oxide layer. So dyes can be added for aesthetic appeal, black, gold and blue. Sealing. The anodizer layer is sealed in hot water or steam to close pores and improve the durability. So this is nothing but anodizing. So here if you observe the chemical reaction, aluminium will react with electrolysis is there. So 6H2O, 6 electrons. It is going to form Al2O3 plus 3H2. Al2O3 plus 3H2. This reaction is known as anodizing. So why we use this one is corrosion. We can make it the material corrosion resistance. It protects against rust and oxidation. Increased durability, harder surface than the untreated aluminium, right? And it gives the aesthetic appeal. It can be dyed in various colors, and thermal electrical insulations is used in electronic applications. So where we use this anodized aluminium is, we can use it in the aerospace industry. Why we can use it? Because it is very lightweight and corrosion resistance coating for aircraft. Similarly, we can use this anodizing in electronics also. So anodized aluminium heat sinks, mobile casings, etc. they are used. And in the architecture also, window frames, doors and decorative panels are designed using this anodizing aluminium. And automotives, parts like wheels, bike frames and engine components are also prepared using this technique. And even cookware, non-stick and scratch resistant anodized aluminium utensils are coming into market. So like this, these anodizing process is having multiple applications. So here the next topic is how the metals are going to react with water. So to test this, we are given one particular activity over here. What we are doing, which metals reacted with the cold water, that we are testing. So by testing this, we are arranging them in the increasing order of the reactivity. So any metal produce fire on water, so metals start floating after some time. These observations we need to do after this activity. So put the metals that did not react with the cold water in beakers half filled with hot water. For the metals that did not react with hot water, arrange the apparatus as shown and observe their reaction with steam. So like this, different ways, water also in different conditions, we are going to test how metals are reacting with cold water, hot water, steam. Like this we are going to test. So after conducting this activity, you can see here we are having a metal sample over here. We have taken a metal sample over here using this beaker, and here water is there. So with this we are testing. So what is our observation is, metals react with water to form the metal hydroxides. In general, you can see metals react and they form metal hydroxide. And which gas is released here? Hydrogen gas is released. You can observe that hydrogen gas. So how much they react with water, that depends upon the metal's position in the reactivity series. So metal position in the reactivity series, that will decide how the metal is going to react with water. So first we test the reactivity with the cold water. So as mentioned here, so if you observe, highly reactive metals in cold water are potassium. Potassium is highly reactive, and sodium and also calcium. They react vigorously with cold water, and what happens once after the reaction, they form metal hydroxide and hydrogen gas will be released. For example, if you observe potassium when reacting with the water, so potassium reacting with water, it is going to form potassium hydroxide in aqueous form, and hydrogen gas is released, and at the same time it is releasing heat energy. So this reaction is known as exothermic reaction. Whenever there is a heat is produced by the reaction, we name them as exothermic. So if they are absorbing the heat, we name them as endothermic, is it not? So here it is in the potassium in the solid form and water in the liquid form, cold water. It is going to form potassium hydroxide, which is in the aqueous form, and hydrogen gas is released. Similarly, sodium in the solid form, when reacts with the cold water in the liquid form, it is going to form NaOH, metal hydroxide, and hydrogen gas is released, and same time heat energy is also released in this operation. So these two are reacting vigorously and moving on the water surface. And what about the calcium? Calcium in the solid form reacting with the water, forming calcium hydroxide, and hydrogen gas is released. So reacts less violently, forming a milky solution due to calcium hydroxide. So here another observation is the reaction of potassium and sodium. This reaction so violent and exothermic that the evolved hydrogen immediately catches fire. Coming to the calcium, so this calcium reaction with water is less violent compared to these two reactions. The heat evolved is not sufficient for the hydrogen to catch the fire. So this won't catch any fire, but what happens is calcium starts floating because of the bubbles of hydrogen gas formed stick to the surface of the metal. That's why it will be floating. And coming to the next reaction, magnesium does not react with cold water at all. So it reacts with the hot water to form the magnesium hydroxide and hydrogen. It also starts floating due to the bubbles of hydrogen gas sticking to the surface. Metal like aluminium, iron and zinc do not react either with cold or hot water. Coming to other materials, aluminium, iron and zinc, they don't react with cold water or hot water also, but they react with steam to form the metal oxide and hydrogen. See how the difference is coming. So here we need steam. It is mentioned as gaseous form. That means we are taking the water in the gaseous form. That is nothing but steam form. So aluminium and iron, they are forming the metal oxides and they are releasing the hydrogen when they are reacting with the steam. So here we can say metals that do not react with water are also there. Copper, silver and gold. Copper, silver and gold and even platinum, they do not react with water at all. They are called noble metals due to their high resistance to oxidation. That's why we are using for the jewelry purpose, right? So how it is varying? That means highly reactive potassium, compared to that sodium is less reactive, compared to that calcium is less reactive, and magnesium then fourth place. So they react with the cold water or hot water also. So coming to moderately reactive, zinc, compared to that iron is less reactive. So these two react with the steam. And coming to this copper, Rm and Ag, silver, they don't react with the water. So these conclusions we can make regarding the metal reacting with the water. Next, now we test how the metals are going to react with acids. In general, metals react with acids to form salt and hydrogen gas. So you can observe here, whenever metals react with the acids, they are going to form salt and hydrogen gas. So the reaction depends upon the metal's position in the reactivity series, similar to the water reaction and the oxygen reaction or air reaction. Here also metal reacting with the acids, that depends upon the position of the position of these metals in the reactivity series. Okay, coming to highly reactive metals. So here, for example, highly reactive metals are again potassium, sodium and calcium. So these react explosively with the acids. These reactions are too dangerous to perform in the lab. You have to be very careful. For example, if you take sodium, it is reacting with HCl. It is going to form sodium chloride and hydrogen gas will be released. So if you balance the equation, it will be 2Na, 2HCl to form 2NaCl and H2 gas. Coming to moderately reactive metals, you already know, similar to water reaction. So magnesium, aluminium, zinc and iron. These are moderately reactive metals. They react steadily producing bubbles of hydrogen gas. Reaction is faster with the strong acids like HCl and H2SO4. So for example, if you observe magnesium reacting with HCl gas, so it is going to form, it is a rapid reaction, produces hydrogen gas, and magnesium chloride will be formed and hydrogen gas will be released. So similarly, zinc, if you test zinc with H2SO4, it will form ZnSO4 salt and hydrogen gas will be released. So zinc sulfate and hydrogen gas are released. This is coming to iron. Iron, when reacting with the HCl, it is going to form ferric chloride and hydrogen gas will be released. Compared to the magnesium and zinc, this iron reaction is slower. And less reactive metals, you all know, similar to the previous activities, copper, silver and gold, platinum. These are very less reactive and they do not react with acids because they are less reactive than hydrogen. So no hydrogen gas is produced in these reactions. So copper plus HCl, there is no reaction. Even silver plus HCl, there is no reaction. Gold is there is no reaction. So reactivity series for acid reactions, highly reactive are first highest potassium, then sodium, then calcium, and moderately reactive first magnesium, aluminium, zinc and iron, and least reactive copper, silver, gold and platinum. No reaction at all. So here we would like to know another interesting aspect about aqua regia. So what is this aqua regia? It is a freshly prepared mixture of concentrated nitric acid HNO3, one part you have to take, and concentrated HCl, that is 3 parts. If you mix these two, HNO3 one part and HCl 3 parts, it is going to form, for example, I will write the equation HNO3 plus 3HCl. What it is going to give? NOCl plus chlorine plus H2O. This reaction produces chlorine, okay, and nitrosyl chloride. NOCl is known as nitrosyl chloride, NOCl, and which help dissolve noble metals. This nitrosyl chloride will dissolve the noble metals also, and this is known as aqua regia. So reaction with gold. Gold is highly unreactive, but aqua regia can dissolve it. So it forms chloroauric acid is a soluble gold compound. Reaction with the platinum also, this forms chloroplatinic acid. So uses, where we use this one is, we can use it for the gold and platinum purification, okay, and it is used in the refining and extraction of gold and platinum, cleaning laboratory glassware, removes organic residues, and dissolving noble metals, essential in metallurgy and chemical analysis, and even you can use it in the etching microelectronics used in the semiconductor industries.